Hi everyone, welcome back to my Network IQ channel. I'm Bob and today we are diving into the world of network topologies, specifically the bus topology. Let's go to our slides. Let me pass these slides and here we go. So what is a bus network topology? A bus network is a type of network setup where all devices such as computers, printers and servers are connected to a single central cable known as the bus or backbone. Imagine it like a main road with houses or devices connected along it. Each house can send and receive mail or data along this road. In a bus topology, every device is connected to the same central cable and they share the communication medium. This communication medium or this central cable acts as a shared communication line that carries the data packets between devices. Additionally, the bus topology uses a broadcast transmission method. This means that when a device sends out data, it broadcasts the data to all devices connected to the bus. Each device checks the data packet, but only the intended recipient processes the data. So this way, even though the data travels to all devices, only the target device accepts and uses the information. Now let's see how it works. In this setup, data sent by one device travels along the bus to all other devices until it reaches its destination. First of all, let's talk about data transmission. When a device wants to send data, it first checks if the bus is free. So it will check all of this medium, and if it hears something, it's not going to send data. So if the bus is free, the device sends the data packet onto the bus. We have a silent period. While one device is sending a packet, all other devices must remain silent and wait for the bus to become free. This helps to avoid data collisions. And then signal travels. The data packet travels along the bus and can be seen by all devices connected to it. So we have an addressing concept, which means each data packet has a destination address, and the device with the matching address pick up the packet and processes it. Other devices ignore the packet. So if the destination is this server, it will pick up the packet and all others will discard this packet. And of course, this is a shared medium. I mean, this cable, this communication medium is a bandwidth sharing medium, which means all devices share the same bandwidth, which can lead to a slower performance as more devices are added. So more devices on the network lead to a slower network. And we call this access method CSMA-CD, and we will cover this concept in other videos, of course. So let's go to the next slide. In this slide, I will show you the tools that we need to produce this network type. We need T-connectors, and this is a real picture of T-connector, which connects to the NIC from this side. And from these two sides, it will going to connect to the cable in this shape, and for this one, and for all of them. And then we could connect this to the computer's NIC, and you should know the failure of each T connector leads to failure of entire network. Why? Because of signal bouncing. What is bouncing? When a data, or it's better to say a signal, arrives at the end of the cable, it's going to bounce again into the cable, and all devices receive it again and again, and it seems that a talkative computer is talking all the time or sending data all the time. So nobody can send any data until this repeated signal disappears. What we can do is to use a tool called Terminator. A terminator is a 50 ohm resistor which is connected to the ground, and we connect this tool to the last T connector of the last computer. So we need two of these terminators, one for this side and another one for this side. It will discard the signal at the end of the cable, at the end of the circuit, and prevents signal bouncing. So in this illustration, we see a rare view of a bus network setup using coaxial cables, and along the central bus cable, T connectors are visible. These are T connectors, this one, or this one, and this one. And these are the terminators. One of them is here, and the other one is here. This setup illustrates the simplified and straightforward nature of bus topology, where devices share a single communication medium, albeit with limitations in scalability and fault tolerance compared to modern network architecture. Now let's talk about advantages and disadvantages of this topology. This is the first advantage: simple setup. It's straightforward to install and configure. You just need a single cable and some connectors, and of course it's so cheap and cost effective since it uses less cable compared to a star or mesh topologies. It's cheaper to set up, especially for small networks. And the last advantage is easy to extend. Adding new devices is simple and you can just attach them to the bus with a new T connector. The first disadvantage of this network topology is limited cable length. The length of the bus cable is limited to 200 meters or less, which can restrict the size of the network. The longer the cable, the weaker the signal. And the second disadvantage is network failure, which means if the central bus cable fails or one of T connectors, the entire network goes down. Unlike in star topology, where failure of a single cable affects only one device. And the next one is troubleshooting. Identifying and fixing issues can be so difficult because the problem can be anywhere along the bus cable and it's very difficult to find it. Additionally, the more devices connected, the more collisions and network traffic can slow down communication. Let's go to real-world applications and example setup. Where would you see a bus topology in real life? First of all, small networks, often used in small home or office networks. And the second one is temporary networks. It's ideal for temporary setups like exhibitions or LAN parties. And of course, early networks, common in older Ethernet networks. You know, while bus topology was popular in the early days of networking due to its simplicity and cost effectiveness, it's rarely used in modern networks. I remember that we used it about 25 years ago. Of course, it was so popular in those days. And this is primarily because bus networks have several limitations that make them unsuitable for today's high-speed, high-reliability networking. And this is primarily because bus networks have several limitations that makes them unsuitable for today's high-speed and high-reliability networking requirements. The central bus cable in a bus network creates a single point of failure, and if it goes down, the entire network is affected. Additionally, as more devices are added, the network becomes more prone to data collisions and signal degradation, leading to decreased performance. And of course, again, troubleshooting issues in a bus network can also be difficult and time-consuming. So modern networks prefer topologies like star and mesh, which offers better performance, reliability, scalability, and ease of management. Let's go to recap and conclusion. In conclusion, bus topology is a simple and cost-effective way to set up a network best suited for small and temporary networks. While it has its limitations, understanding how it works can help you decide if it's the right fit for your needs. So of course, it's simple, cost-effective, it's for temporary network, and it's not used in modern networks. And that's all for today's video on bus topology. If you found this video helpful, give it a thumbs up, share it with your friends, and leave a comment below if you have any question or topics you would like us to cover next. Don't forget to subscribe to my Network IQ channel for more videos like this one. And thanks for watching. See you in the next video.